Are you looking to enter a new career? Or maybe looking to advance yourself in the career you're in? At the University of Guam Global Learning and Engagement, here's where you begin. Enrolling in our online career training program can give you the skills and confidence you need to achieve your career goals. Imagine getting hired at a company or organization doing the job that you've always dreamed of. With over 175 programs to choose from, there's plenty of opportunity for you. You'll dive into the fundamentals of in-demand industries such as business, information technology, health and fitness, project management, and many more. You'll have everything you need to successfully advance your career without disrupting your life. You can enroll at any time, so start today and you're on your way to a new career.
They say there are two kinds of people in this world. Those who find themselves and those who create themselves. Are you looking for purpose or deciding it for yourself? Will you plunge waiting for someone to catch you? Or will you jump and build your wings on the way down? Seek a path or carve a path. Wait for the future or build it. What is a school but a set of walls waiting for greatness? And who are you but someone destined to achieve it? Here, between the street and the jungle, against time and tide, we push and pull just like the currents. Our ocean of dreams will meet the odds ahead and rise above it all.
Half a day, everyone, and thank you for joining us for the first day of the Weri Advisory Council meeting focusing on Cnmi. Without further ado, it is my honor to introduce you to Dr. John Jensen, the Director of Weri, for welcome and introductory remarks.
Good morning. Half a day, everyone. I see we've got about almost 50 people signed on. There's a lot of familiar names. Unfortunately, I can't see all your faces, but I'm getting used to this business of speaking into TV monitor with everybody out on the other side. We had hoped that the COVID pandemic was going to be easing up by now and we'd all be back to getting together at the downtown locations, such as on Saipan when we meet at the PIC and we all have lunch, but that's not happening yet. The good thing is we've got Glee and the support here at the UOG is terrific here for pulling these things together. These advisory council meetings, as you know, are the central event for Weri each year for us to connect with all of you, our constituents, the people that we do this science for. And that's one of the rewarding parts of the job is that the science we do is directed at solving problems and solving problems in a very important part of people's lives, which is the water we drink. And we take it for granted when we get up in the morning and shower and have breakfast and the water's running. But one thing that people in the Western Pacific know about is what it's like when you go for a few weeks without water after a big storm, and we don't take it for granted out here. So it's a pleasure to work with the community of all you professional people, and policy to the regulation, to the technical aspects of it, and making this happen. And it's a pleasure to have you all as our partners. This is the first of our annual meetings. We're going to be meeting next week with the FSM Advisory Council meeting online on the 27th. And then on November 6th, Wednesday, November 17th, we'll have the Guam Advisory Council meeting. And I'm looking at all the names and people that I work with, and Pleased to have you here. It's also my pleasure to have our Senior Vice President and Provost, Dr. Anita Enriquez, with us to open the event for us. Dr. Enriquez and all of the senior administration at UOG are great supporters of Weri and our mission, and the institution, University of Guam, is well led. Makes it an easy place to work and rewarding place from which to contribute to the community. So it's my pleasure to introduce Dr. Enriquez and invite her to share a few words with us. Dr. Enriquez.
Sijus Masi, thank you so much, Dr. Jensen. Hafa buenas, and manana sijus, ladies and gentlemen, good morning. It is my pleasure to welcome you to Weri's annual advisory council meeting for the Commonwealth of the Northern Mariana Islands, and delighted to be here. This is our second online meeting for the CNMI Advisory Council, and I've been advised that there are 67 participants registered as of yesterday, and we can see from the Zoom screen, we've reached about 50, almost 50 who are joining or logged on now as we're getting started. In the recent pre-COVID years, we met in the meeting room at the Pacific Islands Club, which we always capped off with PIC's renowned lunch buffet. Even though the pandemic has shut down such meetings and the buffets that went with them, the online meetings seem to be reaching a growing circle of people throughout the region. That may reflect the excellent work that our staff at UOG's Global Learning and Engagement Center do in orchestrating these events for us. And I'd like to acknowledge Amanda and Justine for the fine work that they have done and are doing even this very moment in organizing and managing this virtual event. The University of Guam is dedicated to serve the entire region and is so proud to collaborate with Northern Marianas College and to count among our own students, faculty, and staff, many outstanding contributors from the CNMI. And of course, we are attending this morning's meeting with the Water and Environmental Research Institute of the Western Pacific because it is the Water Resources Research Institute for the CNMI, as well as for Guam and for the Federated States of Micronesia. And we recognize among the participants of this meeting, lots of names from the rest of the region, especially Guam, and even from Hawaii and the States. One of Weri's strengths is that it is the technical and intellectual hub of the entire regional network of water resources professionals, including environmental scientists and engineers, water resources managers, regulators, and policymakers, as well as educators and students. At UOG, the Weri faculty are among the core of our graduate environmental science program. Weri has funded the thesis projects of about 40 of the nearly 70 students who have graduated from the program since it awarded its first master's degree in environmental science in 1997. And it was members of the Weri faculty who, beginning in the 1980s, implemented and taught the two-year pre-engineering program, which eventually evolved into the new School of Engineering, chartered in 2016. The founding dean of the school, Dr. Sharam Prasarpana, also known as Dr. K, as most of you know him, was one of those former Weri faculty who taught pre-engineering courses. I would also like to mention that Weri is among the select group of state and territorial water resources research institutes that received the U.S. Geological Survey's top rating of outstanding in its latest 5-year review of the nation's 54 water resources research institutes. And Weri is now poised to put up a new 3-story building on UOG's main campus, in which its water quality laboratory, which also serves the region, will have twice the space it now does. We expect to have the design selected early next year and the building up by the end of the following year. Something to celebrate. In a few minutes, you're going to hear from Weri's director, our very own Dr. John Jensen, faculty, and student research assistants who will describe Weri's mission and mandates in a bit more detail and will report on the progress of current projects and seek your insights, suggestions, and advice. I'd like to note that Weri's approach to water and environmental science is not to merely follow their own interests or the topics with which they are most comfortable, but rather to identify problems that require new or better scientific understanding and then seek solutions to those problems by gaining some new or better understanding needed to help solve the problem. Most of all, they are dedicated to providing the region's policymakers, water resources and environmental managers and regulators, civic leaders, engineering and technical professionals, teachers, and students with reliable, valid data and sound interpretations of the data, objective and honest advice, superb instruction, and useful information for sustainable management and wise stewardship of our regional freshwater resources. Suzusmasi, and thank you for joining us this morning. The kind of two-way engagement that we are seeking this morning is an essential ingredient of successful science. I'm looking forward to hearing from all of you as well as from our Weri faculty, staff, and students.
Okay, looks like we're good to go. Thanks, Anthony. I'm a little technically challenged here on operating Zoom, but as Dr. Enriquez mentioned, you're going to hear a little bit of detail from me now on the mission and mandates of Weri. And this is one of my favorite topics because Weri's been a great place to work and a rewarding experience for the past 28 years, and it just keeps getting better. We're one of the 54 water resource research institutes in the U.S. Geological Survey's nationwide Water Resources Research Act program, which is the federal-state partnership created by Congress back in 1984 to conduct research on state and regional water problems, share research results, train new scientists and engineers. Those are our federal mandates: state and regional water problems, research results, and training of new scientists and engineers. We also have local mandates and local funding to support the partnership with USGS and provide technical and educational support to local managers of the island's water resources. And I'll say more about that in a minute. So I'm going to review the composition and mission of Weri and summarize our activities, services, and products in support of the national programs, objectives, and the local mandates. We have 7 faculty, of which 1 serves as director at any given time, and our expertise covers the whole water cycle and the human use sequence, from rainwater to surface water and groundwater, and ultimately to wastewater treatment and disposal. So we have specialists in hydrogeology, water quality engineering, and geospatial analysis to support this work. And we're one of only 2 of the national institutes with its own research laboratory. And I'm also blessed with the world's best administrative staff, which keeps us in business. And I always like to brag about the enormously talented team of graduate and undergraduate research assistants that are Weri's scientific labor force. Student research assistants, especially the graduate students engaged in their thesis research, are the frontline troops of science everywhere. You're going to be hearing directly from some of them this morning. And we have students in various stages, some poised to graduate, some just getting started, and some in between. And you'll, as you work with people at Weri, you'll be working with our graduate research assistants, who are the ones that do the heavy lifting. I'll say more about that in a minute, but these are the ones that do the field work, the lab work, the tedious work that has to be done to collect specimens and analyze samples. And these are the people who do it. We're real proud of them. So that's who we are. And now I'd like to go on to what we do. Weri is unique among the 54 national institutes in that we have a regional mission to 3 communities: Guam, Cnmi, and the FSM. And our success owes to our reputation for doing good science for the benefit of the region. We're committed to trustworthy and timely research, instruction, and advice to support scientifically informed development and effective management of freshwater resources of Guam, Cnmi, and FSM. Our core values are honest and reliable science, superb instruction and conscientious mentoring, earnest service to the community and the university, sincere partnerships with public and professional agencies, and consultative decision-making, and across the board teamwork. We take these values seriously. To clarify even more what we are, I always like to point out explicitly what we are not. We're not activists, we're scientists. And we're not driven by political correctness or fashion. We follow the data, not the funding or the fashion. And we're not yes men or yes women. We share both the bad news and the good news with our partners and clients, and partner with people with whom we work in all contexts. We're team players and public servants and fellow citizens. These are the product standards that we put on our reports, and we make it clear that we do our best to work with the best data and offer you the best professional judgment. We engage in debate on scientific technical issues, and we welcome criticism and requests for clarification and updates. We don't withhold, withdraw, retract, or alter our observations in the face of political, commercial, or other non-scientific concerns. So I'd like to move on now to our primary activities. And I'd like to start with 1998. Although our mission is to the entire region, Weri gets dedicated annual funding from the Guam legislature for research, education, and outreach on Guam. The Comprehensive Water Monitoring Program funds our participation in the USGS National Groundwater and Stream Flow Information Program, provides essential data on rainfall and stream flow, thickness and salinity of freshwater lens in the aquifer. The Guam Hydrologic Survey Program funds the research that utilizes these data to assess conditions and trends in our water resources. The legislature established these 2 programs back in 1998 when the record-setting El Nino brought an extended and severe drought to the region. Surface water resources were stressed, and there was widespread concern that their groundwater might become salty. 2 bills passed by the legislature rehabilitated our data collection program and established permanent funding for our partnership with the USGS Pacific Islands Water Science Center to service instruments and collect the data. This kind of support for the work on Guam from our local legislature leverages the funding that we get from other sources so that we are better able to serve the rest of the region. And we're grateful for the support we get from our local government here. Where's local knowledge of water resources in the region started 50 years ago with the establishment of UOG in 1975. Our partnership with PIWSC in Honolulu began in '98 and has now spanned more than 2 decades. We picked up the mandate for Federated States of Micronesia in 1994 and for the FSM in 1997. And we've been as I mentioned, unique in that we have a 3-in-1 mission, a regional mission to all 3 constituencies, Cnmi, FSM, and Guam. So I'd like to highlight some of the accomplishments of this partnership with USGS that began in 1998. In September of 2013, we concluded a 3-year study sponsored by the Marine Corps and led by Steve Gingrich, then at Pacific Island Water Science Center, built and apply a groundwater model to examine the effects of increased withdrawal on Guam. Besides the model, the project included a big expansion of our aquifer database and more detailed and accurate state-of-the-art map of the aquifer, new assessments of aquifer recharge, responses to pumping. And this study was addressed at the very obvious practical question of how existing systems of water wells would respond to additional development. This has been the basis for an ongoing program of modeling, which we've developed on Guam, and we have the potential now to expand this kind of work into other islands, and we've done some modeling on the atoll islands in FSM a few years ago, and are positioned to expand this kind of work again. I'd like to mention that these projects have ranged from NSF-sponsored basic work on paleoclimate, sea level history, aquifer evolution, climate trends, and we've had a variety of projects over the years. You're going to hear about the current ones now, but we've worked on the water distribution system in Saipan, the wastewater treatment in Yap, and water quality in Guam's groundwater. We work on climatic phenomenon. We have a meteorologist who you're going to hear from in a few minutes, who's one of the world experts on tropical cyclones that affect the entire region. And of course, that's something that all of us who live in the Western Pacific have to deal with. Just to give you an example of the results of the monitoring program that we have here on Guam with USGS, we're able to track the thickness of the lens as it increases and decreases in response to changes in the wetness and dryness of years and series of years. And this is essential for calibrating groundwater models, and it's essential for being able to advise water resource managers of the condition of the lens and the effects of pumping, as well as effects of natural changes in recharge. And this screen shows the thickness of the lens in the middle of the Jigotuman Trough, where it's about 100 feet thick on Guam. And I may get a chance to mention during our open discussion, and I've got my partners from USGS on here. But these kinds of programs are potentially available to extend this collaborative work with USGS and to CNMI and FSM, and we've had various times in the past GS hydrologists in the CNMI and FSM to work with us on these similar kinds of projects. As I mentioned, the graduate students are the frontline troops of science, and we have a team of undergraduates that are we're trying to groom to follow in their footsteps. But besides the exciting stuff, and I tell them graduate school is the fun part of doing science. It's where you get to go out in the boats and hike in the jungle and explore the caves. So you do the exciting stuff, you do the arduous stuff, the time-consuming, repetitive, mind-numbing entry of data into the spreadsheets, but indispensable heavy lifting of all the levels of scientific research, from collecting samples, analyzing samples, building databases, filling spreadsheets, computing statistics, plotting graphs, generating maps, configuring models, preparing reports. We usually have about 6 to 8 student research assistants on the payroll at any given time. And we try to tap the talents of recent graduates for 2 and 3 year stints as full-time or part-time research associates to support our field research. So, as I just mentioned, the frontline troops are our student research assistants. So successful research starts with recruiting, equipping, and training the troops. And as I noted, training new scientists and engineers is one of our national mandates. So it's from both enlightened self-interest and a sense of obligation that Weri faculty founded with our partners and the rest of the university faculty, the Graduate Environmental Science Program back in '94. And we've graduated about 2/3 of the between 60 and 70 students that have finished it. And as Dr. Enriquez mentioned, the pre-engineering program was an initiative from Weri faculty members back in the 1980s. We've provided support to the new School of Engineering. The late Dr. Rouse assisted in putting together the curriculum, and Weri faculty have helped staff the search committees until they got their own faculty in place to work on those sorts of things, and we work with them now as research partners. I want to show off our brag wall with the 25 or 30 thereabouts alumni and students who still live and work on Guam and in the region, including 3 of our alums at Guam Waterworks Authority. But we're proud to have Jennifer running the lab at GWA now, and we got Mallory Duenas stepped up to the task and is managing the lab here and doing a great job. So we have we support GWA and Navy's engineering operation here on Guam. And this is our current lab staff. The lab is one of the crown jewels of Weri and serves the region with a expanding set of services. And as Dr. Enriquez mentioned, we're going to be getting a new building. We're going to double the lab space and increase our services. We've got the Northern Guam Lens Aquifer database. We've got the map of the aquifer and annual reports on the state of the aquifer here. So I'll leave the stage with this scene from one of my former students in one of our underground laboratories. we pride ourselves in being out in the field and collecting data and working with the professional community to solve the practical problems with water resources. And I've run out the clock, so I'll step off the stage here and turn it back over to our moderators. And I'll save the questions for our open discussion period later.
Hi, good morning, everybody. Just give me a second, please. I can share my presentation. Hi, good morning, everybody. Thank you for having us all here. My name is James Pangilinan, and my supervisor for my current research is Dr. Chris Yeo. And our presentation is titled Phase 1, A Sustainable Plan for Stormwater Management and Flooding in Saipan. However, we should mention that we will also be talking a little bit also of results coming from Rhoda as well. So the impetus for our research comes from extreme precipitation events, in particular the consequences of them, which are floods. These flooding events account for more losses than any other natural disaster, both in terms of lives lost and economic costs. It's been estimated that the average annual flood damages in the United States are $2.1 billion. And it's been shown through some studies that increased trends in number of natural disasters are exhibited. Here you can see an illustration by Peterson and others in trends in flood magnitudes, where the larger triangles correspond to increase or inverse trends of changes in flood magnitudes. You can see that in the east, northeast region of the United States, it's much more prevalent to experience, or they have experienced positive increases in flood magnitudes changes per decade, and a little strewn and sprinkled throughout the West as well. You can see it. It's not as much, but it's observable there as well. And so understanding the variations of the rainfall process in time and space is essential for planning, design, and management of various hydraulic structures. So a little bit closer to home, according to the Department of Emergency Management in Oahu, in Hawaii, they average about 11 flash flood events per year. They experience it more frequently during the wet season. However, it is possible to experience them at any time during the year. And they have also mentioned that of all weather-related disasters that occur in the United States, flash floods are the main cause of death. And so, how do we quantify these extreme precipitation events with relation to its specific duration and return period? We utilize the method of called design rainfall, and the results of this process is statistically put together in what's known as intensity, duration, frequency curves, or also known as IDF curves. Here's an example of what an IDF curve is. So you can see that they're on the left vertical axis. This corresponds to the intensity of the precipitation event in millimeters per hour. The horizontal axis on the bottom corresponds to the duration, or how long the rainfall event occurs. Typically, this is measured in minutes and hours. And you can see that the segments that are sketched on the graph correspond to the frequency of rain events, where each of the lines in the graph show how often a rain event occurs. And this is measured typically in years. So when constructing these IDF estimation curve or IDF curves, we have three issues to solve when constructing them properly. One of them is the time scaling issue. The other is the spatial scaling issue. And also considering the effects of climate change, it should be also inputted when constructing these IDF curves. Today, we're going to talk a little bit about the time scaling issue as well as the climate change issue. So with regard to climate change issues, impacts from climate change on precipitation have been recognized as one of the most crucial issues for water management. Today, we typically use general circulation models to quantify climate change effects. However, it's not suitable for impact studies at local site, considering that the outputs of these models are quite large and span a huge space. And also the time duration of the outputs are typically in daily intervals. So you can imagine for the extreme rainfall event that we should try to understand, or we should try to I guess study the extreme rainfall event not in the daily time frame of things, but more so in more fine-tuned durations, considering that they happen in those time scales. So to sum up, the overall objective of our research is to build up the best method for estimating accurately extreme rainfall events for current and future periods in the Pacific. We've devised sub-objectives that will help meet the overall objective. The first sub-objective is to conduct at-site and regional frequency analysis. The second is to investigate scale invariance properties of extreme rainfall for the Pacific. And the last is to develop the extreme rainfall estimation model coupled with climate change, the effects of climate change. So again, we'll go ahead and talk more deeply about the first two for our discussion today. So to highlight the first point that we'll go into, conducting at-site regional frequency analysis using AMPs, or annual maximum precipitations, but I'll go and just call them AMPs from now on. So the study areas from which we were able to gather results from, in Saipan, we were able to gather rainfall data from two specific sites, that is the Saipan International Airport, as well as Capitol Hill. And in Rota, the specific site we were able to gather rainfall data from was from Rota Airport. It should be mentioned that from both sites, the data was retrieved from the National Weather Service. Okay, so in order to tackle the time scaling issue, we should go ahead and talk a little bit about the some of the important concepts when trying to tackle that issue. So overall, we use the scaling GB distribution method, which harnesses the idea of the GB distribution as well as scale invariance properties. So I just want to highlight the GB distribution, which is characterized here by its cumulative distribution function. This type of distribution is characterized again by the three parameters, the alpha, psi, and kappa parameters, or also known as the location, shape, and scale parameters. There was a study from Pandy, or there was a paper by Pandy who suggested that there is a link between, or a relationship between the parameters and what's known as the non-central moments, which is key to, which is a key idea in this utilizing this method. Essentially, the non-central moments are the expectations of some random variable to the kth power, where k is the kth order non-central moment. So it's basically taking the means of some random variable to the power of some integer. Should I say some natural number? Okay. So the limitations of the conventional way of actually finding the parameters for this distribution is the method of L moments. However, the limitations of using this method is that when you construct the parameters for a distribution, when you construct the parameters for the distribution, it's only fitted or more, it's only accurate for that particular time scale. And so if you wanted to take a look at the parameters in a more accurate scale at a smaller time interval, you're unable to do so with this method. So there's this need for what's known as these scale invariance properties, which are highlighted by these equations here. So essentially, what you have is that if you're able to, for the method, for the scaling GV distribution method, if you're able to see if the non-central moments of the observed data exhibit some form of scaling, simple scaling, then you can use these scaling equations to find the parameters of the distribution at finer time scales, which are highlighted by the left side of the equation. So the right side, if you're given daily, the parameters coming from the daily time scale, then you can use that multiplied by some lambda to the power of beta, where lambda is just a ratio between the shorter duration that you want to cover to the longer duration that you are given. And beta is known as the scaling exponent. So ultimately what you want to do is you want to try to solve for this beta so that when you have, since lambda will be given alpha sub t, psi sub t, and beta and kappa sub t, all of these would be defined at the beginning because you'll be given the high resolution, the daily parameterizations. If you can solve for this beta, then ultimately you can solve for these sub daily interval level parameters. Okay. Okay, so to demonstrate the feasibility of the alternative parameter estimation method or the scaling GB method, the comparison study was carried out from to the observed data and the estimated quantiles in these graphs. So both the conventional estimation method using L moments and the proposed method are applied to the observed data. The quantiles are estimated with the exceedance probability and the determined sets of parameters of the distributions for a given duration. And you can see from each site, the observed data are given by the points and the quantile graphs generated by the L moments and the quantile graphs generated by the NCMs, or the blue dash lines and the red dash lines. They follow very closely one another, which we can say that this shows the feasibility of using the proposed method, the scaling GV method, which utilizes NCMs in the parameterization process. Okay, so for the second sub-objective, what we want to do is to investigate the scale invariance properties of AMPs, if any, in order to account for the relationship between AMPs with different time scales. Okay, so just a reiteration of what scaling invariance properties are and how they're helpful rather. So scaling invariance properties of extreme rainfalls have been used for temporarily downscaling sub-daily extreme rainfall from daily extreme rainfall in association with several probability distributions. And ultimately, once the scaling invariance properties of AMPs are built, then we can build these statistical properties for shorter durations using those scaling exponents and the ratio of shorter time scale to longer time scales. So here are the scaling properties of the AMPs in Saipan as well as Rhoda. In the top row correspond to the NCM graphs for the first three NCMs or the first three non-central moments. You can see that for each graph, there is a, I should also mention that the graph is scaled log linearly or log scaled. And you can see that there's a break between, for each NCM graph, there's a break. That's the distinction between short-term intensity storms and long-term intensity storms. And each of those graphs have their own slopes, as you can see, right? One's tilting a little bit higher than the other. And those slopes are, we can call them the scaling exponents. Mathematically, you can see that if we solve for it using logarithmic properties, but I won't get into that. Ultimately, what's important is these scaling exponents, right? What they are. And you can see that corresponding respectively for each graph on the top rows are the simple scaling tests of the scaling exponents for the short-term intensities and long-term intensity durations. The blue lines correspond, you can see have 3 points. Those 3 points just correspond to the values of the slopes for each short-term intensity storms, and just plotted. And the red graph is comprised of 3 points. Those 3 points just correspond to the slopes of the long-term intensity storms. And if you plot them, you can see that there's a linear fitting to these scaling exponents, which we can infer that our NCMs follow simple scaling properties or have simple scaling properties. And so estimating the quantiles generated from the first moment and third moment, we graph them on, and we include the quantiles of the observed AMPs as well. And you can see that there's a good fitting of one of these moments, namely the third moment or 3 moment, to the observed quantiles. And so based on this comparison, we can say that the scaling GB method is practical for estimating sub-daily and sub-hourly AMPs using only daily AMPs. So what are our future activities? Well, first we want to compare, make more comparisons of estimated quantiles to observed data for smaller durations. And ultimately, we would like to generate IDF curves with respect to each return period. We should just mention that the estimated IDF curves will be used for stormwater management models for describing urban floods. And with regards to the climate change issue, we would like to develop the model coupled with climate change scenarios for assessing climate change impacts on the extreme rainfall process. And I believe that concludes my presentation.
Thank you, James.
Thank you so much, James, for your great presentation. At this time, if there's any questions, you can share them in the chat. We also do have a question if we'd be able to share your presentation with the attendees today via email after the meeting. Is that okay?
Sure. Perfect.
So for those of you who have sent inquiries regarding a copy of Mr. Pangalinan's presentation, we will send that out for you today in email form. Oh, I believe we do have a question from Mr. Edwin in the chat for you, James. Before we go into our break, I'll just share this question for you. Hi, do you have shareable report relating to this presentation about the scaling method?
If the question is, if I may reword the question, is the question related to, are there any relatable studies on using the scaling GB method? If so, yes, I can share with you. It's actually, yeah, we can do that, sure.
Yes, in addition to James, I developed already one model. So I'm preparing some journal paper. So I believe we can submit this paper to journal journals next week for Guam area. So James and I used 7 language data for this model. So we found very significant achievement. So with this achievement, we're gonna prepare that. So I believe we can share this paper or some report with you.
Perfect. Thank you so much, Dr. Yo, and thank you again, James, for the great presentation. At this time, we're going to go ahead and move on to a short break before we move on to our two last presentations for today, the hydrological data for CNMI, a preliminary analysis, and a summary report of PFAS and Saipan's water system. Thank you again, James. Great presentation. Good day, everyone, and thank you for joining us for day one of the Weri Advisory Council meeting. Without further ado, we bring you to our next presentation by Dr. Mark Lander of Weri on hydrological data for CNMI, a preliminary analysis.
Yeah, can you hear me?
Yes, we can. We can hear you clearly, Dr. Lander.
Yeah, that's good. Yeah, you have my slideshow, so I'll have to give you an indication when to change the slide. But
at this time, we'll go ahead and pull that up for you and we can start now.
Okay. All right, my opening slide, can everyone see it? I guess so.
Yes, we can see it.
Okay, yeah, there's my title. That picture I took about 2 weeks ago. I talk about extreme rainfall. There's the scale of it. That's Apra Harbor, Arroyo Point to the left and the commercial port to the right. That was probably 4 inches an hour rainfall rate. On that scale. So that's the kind of problem I think we're working with. Anyway, next slide. Oh yeah, all the typhoons, let's go through that quickly. Next slide. 2018, Super Typhoon U2, I was there. I went up the night before to actually get in it and weathered it out on Saipan, but next slide. Everyone remembers. I don't know how I haven't been up to the island much since then. Next slide, there's some U2 damage. The college, I don't know what's the condition? Anyone from Saipan can put it in the chat or say, but that's what it looked like the day after U2. Next slide. There's the water run up. Surprisingly, the big waves, the water was up about 20 feet. The big waves surge, the white water goes all the way up to the cliff line there and kind of crushes all these weeds, but that's an oceanic effect from waves. Next slide. Then Sodalor, of course, was 2015 and similar kinds of destruction on the island. So Saipan's been getting hit. And Guam, we've been 2002, what are going on 20 years now with no typhoon. So next slide. Now for the show. All right, next. There's just some nice pretty pictures. My wife made me get an iPhone and I take pictures of clouds and sunsets and things with it. Next slide. Okay, climatic variables. We'll do sea level rainfall typhoons, the things we worry about here in CNMI and Guam and FSM. Sea level is one of the climate ones. Next slide there. Okay, that's just an introductory slide. That's an actual picture I took during a tropical depression a couple years back. Kind of glorified it with Paint Shop Pro. Next slide. Okay, sea level, the sea level throughout Micronesia, everyone does the same thing, whether it's Palau, Majuro, Guam, Costa Rica. Saipan, the sea level for one kind of gets the flavor of the sea level for all. Here's the sea level at Guam. I do different things with data than most people do. With the sea level data, I separate it into two. From the beginning in the 40s to 1997, 1998 onward. After the 97 El Nino, the sea level jumped up and stayed up. It was a step function. It wasn't just a monotonic increase. There's no linear trend here, which everyone will say, oh, the sea level is going up by X centimeters per year. It's not what it did. It didn't do anything from 1948 to 1997. In fact, it slightly fell and then jumped up and then stayed up. Even right now, on the right-hand side, we're very high. As we speak, the sea level is very, very high. Next slide. And the sea level variation here is not much to do with climate change. It's all forced by the trade winds. The blue line in this chart is the trade wind strength across the equatorial Pacific, which goes up and down with El Nino predominantly, and trade winds got stronger. After the 97 El Nino, the trade winds got very strong and stayed strong and pushed our sea level up. Of the total rise that's there now, about 20% of it could be considered climate change effects for the whole time series. So if it's up half a meter, then 0.2, 20% of that is the climate change background. And the majority of it, 80% of it, is the trade wind forcing. Next slide. And there's just another, it's a real climatic hockey stick. It shows up, the sea level and the trade winds just are in lockstep. And when the trade winds jumped up in 98, the sea level jumped up and stayed up. And this shows it dramatically. This is not climate change. Our sea level is very high right now, predominantly because the trade winds got stronger. Now, someone might ask, well, that's climate change. I said, no, that's not. The models in climate change actually predict weaker trade winds. So this stronger trade winds at least is not a predicted effect of climate change. So you can't say that that's, so they throw it into natural variability. Well, if it's not climate change, then it's something that just cyclical, maybe come back and go. But anyway, that's the story on sea level. You'll get an opinion of it or a description of it from me that you'll never see anywhere else. Next slide. And next again. Okay. Now on to Saipan. Those are too nice. I should have put it in color, but I scrounged up and found these black and white. That's from Wireless Ridge, I think 2018 or 2019, some fires, big fires up there. One of the aspects of no rainfall, but it's interesting. We get so much rain here and Saipan. Guam 100, Saipan say 80. But even with that amount of annual rain, it still dries out enough in the dry season to have spectacular fires. Next slide. Just a map of the different stations. You can get rainfall. Some, not complete. Saipan has one of the most piecemeal climatic data of any place, where you got the all over the place for limited amounts of time. You can stitch them together or relate them to Guam because our rainfall is somewhat similar. Next slide. I've collected a database of them all. That's just the top of it. Rhoda, Capitol Hill, Tinian, PGSN, the airport, and there's another one. Chip Guard has maintained a manual record, and it's different from the ASOS record. Next slide. Here's just the Saipan International Airport, moving average. You can see that's kind of what the data looks like. Next slide. The Rhoda, same. Rhoda is wetter than Saipan almost all the time by a standard amount, some percent. And here's an example of Rhoda red, Saipan blue, and Guam is a little bit wetter still. So, but we all kind of do the same thing, and all of those ups and downs are related to El Nino. Next slide. Here's an example that James showed earlier, the effect of typhoons. Without typhoons, the extremes of rainfall would be much, much less. Under the 10-year return period, maybe up through 10 inches in 24 hours, you could get from any other thing, but you can't get 15, 20, 25, or 30 inches of a rainfall in a day without typhoons. And they change the entire record. It's a mixed distribution of things. Everything else, and then the typhoon that creates another sort of its own distribution. Okay, next slide. And there's an example that I simulated just a regular gamma distribution. For standard distributions, gamma, log normal, whatever, you just cannot Gumbel distribution. You can't model our local rainfall distributions with a standard curve. That's why James, they're doing the generalized, the GEV. You get around that by just fitting the curve with the parameters. But what they're trying to do then is fit the blue dots to the red dots with some tweaking the parameters. Okay, next slide. Next slide, that's just a long-term record. Let's see what we get to. Somebody has to keep me honest. I always run out of time. Next slide. Next again. Okay, stop. Typhoons. Interestingly, the risk of a typhoon on Guam and Saipan is about the same. You can see on the left in the Pacific, the highest risk of passage close to some distance is northeast of Luzon in the Philippines. And moving out to Guam, it drops off, but Guam and Saipan roughly are in the same 3 to 4 named storms per year, track within, say, 200 miles of the island. In Guam and Saipan, there's some evidence of a split track, some going south of Guam, another batch that goes up into the Northern Marianas, but roughly the same. That's why the extreme rainfalls for Guam and Saipan, the distribution is the same. If typhoons are causing it, it's the same. So you have the same risk of getting 20 inches of rainfall in a day as we do, but not the same for other things. You're drier. But the typhoon risk and the typhoon rain and the wind for the 100-year wind, for the 100-year rain, your risk is the same as ours. Next slide. Okay, this year, I'm going to, now the current, this year is a strange year. 2021 on the left, we're La Nina right now. Our typhoon distribution, the numbers are down. Micronesia has had almost nothing. Go back to 2015 on the right side, you can, what a difference El Nino makes. Unbelievable. And so far this year, absolutely nothing. Off to the west, and only 6 typhoons in the whole basin so far this year. An extremely low number. Next slide. Here's the number, the JTWC number of typhoons. The interesting thing about this, the blue year actually was last year, the blue one on the right-hand side. This year, we're of occurrences of typhoon, August, oh, we're up to 6 through October. So we're very low still, but notice the trend is extremely down. Is that climate change? We keep hearing from climate change people that it's going to go up. We're going to get more, and they're going to be more intense, and so forth and so on. But next slide. Actually, here's the answer. Well, it's not the answer, it's projection. Here's the actual projection. And many of you probably have never seen this or even heard of it. That some of the downscale, or some of the numerical projections, climate model, they cut our typhoons in half. The top image with the pink is the current number of typhoons tracking per such and such a distance from the spot. The bottom one with the blue is the reduction. And this dark blue, which Saipan is almost in, is like it gets cut in half. So the projection, the real projection is cut in half. And it only needs a 15% cut to exactly eliminate any possible risk of an increase in intensity. So the climate change picture on typhoons is probably their projections, not mine, is actually probably what you've never heard before. It gets cut dramatically. Westpac is the biggest loser. That TV show, we are the biggest loser in the entire planet. Our typhoons just get decimated in an extremely warmer world. This is the worst case scenario, but also most scenarios cut us down, cut us down. The only place that goes up a little bit is over by Mexico and between Mexico and Hawaii. That little zone in the simulations, I'm not going to say it's real, but the simulations say that's the only place in simulations that gets more. Everywhere else drops, and we drop the most. Okay, next slide. Okay, I'm getting down towards the end of my talk. What I've been doing here at Weri is I just collect data and laboriously collect. I go to these websites where there's hourly data. I collect hourly and daily max and min temperatures and rainfall from the hourly reports. There's millions of them, and I'm slowly accumulating time series. And these get around the missing data. I can go through, for instance, Anderson Air Force Base, there was 300 missing days in the NCDC data. Going back to the METARs, I brought that all the way back. There's only 11 missing days for real. And those are Christmases, a New Year's Day or two, and a couple of days the station was down for typhoons. I completely filled in the database and got over 280 missing days and populated the data set. But it's laborious, takes months, and I go through millions of hourly reports and sift through them and populate these stuff. And I'm slowly doing it for Saipan. Next slide. Here's an example, Saipan hourly temperature. The hourly, I go through all the reports and get the temperature every single hour. And here's a graph of it, just for 2019, only for the summer of 2019. Next slide. Here's the, I got rainfall too, but here's sea level pressure. I got rainfall, pressure, temperature. There's the hourly pressure for Saipan. And you see when the typhoons go by, the monsoon, the pressure drops really low, goes back up, pressure drops there in August, late August, early September 2019, the monsoon came in, had a big rain, 6 inches of rain and good southwest winds. So this is the kind of thing I'm populating, and it's extraordinarily laborious. Months and months and months of just painfully extracting data. Partly I cannot give this to a student because when I check the data, there's errors in it. It's like, oh my God, it's unbelievable to get this out. But anyway, woe was me, but whatever, I have fun. And you get out some, it's good information. Next slide. Now another problem with Saipan, automated weather collection. They're ASOS. You have an ASOS, Automated Surface Observing System at the Saipan Airport. We have one here, you have one there. And the US, mostly since about the year 2000 or so, the entire network of observing, the people are taken out of the loop. No more a guy at Guam Airport goes out and measures the wind and rain. A machine on a rack at the end of the runway gets all of the data, and it screws up. At least it did here. Here's the rain. Just the Saipan ASOS is always lower, almost always. Here's the actual difference between CHIPS, Cooperative Observer, rain at the airport within a kilometer of the ASOS. His rain is the difference between his rain and the ASOS are these black dots. Above the blue line means the Cooperative Observer reading the rain gauge with a stick and a ruler, measuring, putting it in there, looking at it, almost always gets far more rainfall than the ASOS. So your ASOS is notoriously underestimating the rainfall at the Saipan Airport. This might be a universal problem. I have, because it's so labor intensive, it's almost impossible to go through the entire country or everywhere else to check if this is happening elsewhere. But it has happened here, and they came up with a reason. There was a screen that had got covered with bird feathers or some kind of junk. They put a screen over it to keep the bird poop, or I forget how it was, bird feathers, gecko eggs, from getting in the rain gauge. And that screen itself ostensibly was causing the shortage. And it even might, it doesn't quite explain this time difference, but whatever it is, there's problems inherent in climatic data that no one has a clue that they exist. And it's substantial. This difference could entirely overwhelm a climate signal, for example. If you're trying to find a climate signal, it might be overwhelmed by just an error in the data. Anyway, next slide. This recurrence intervals, I think that's just a throwaway slide. But next slide, I think that was my last slide. No, next slide. Oh, state of the climate. This is near the end. Next slide. Where are we now? I think if you hit there's a couple of animations here. If you hit go next and see if it works. Yep, next. Okay, that's it. Stop there. Those two El Ninos. This is an index of El Nino. You see 2015 was a big one. 2018 was a moderate one. And then now we're in La Nina. We're down here. The index isn't very strongly La Nina now, but the climate is extraordinarily La Nina. Strong trade winds, typhoons shoved all the way to the west and north. Everything you can think of to do with La Nina is happening, even with the index being sort of in the almost not La Nina to La Nina. So next slide. I think this is my last slide. Maybe not. Oh, I forgot I animated that. Next slide. El Nino kind of stuff. El Nino means a lot of things here. It means all the things. You get floods, then drought. You get typhoons and then no typhoons. So when you say El Nino means drought, no, it means everything, but at different times. So that's a whole other sort of talk about El Nino. Next slide. I think that was my last. Is that it? Yep, I'm done. Yay.
Thank you, Dr. Lander, for the presentation.
Yep.
So our next presentation is on the summary report of PFAS in Saipan's water system.
Hi, everyone. Let me share my screen.
Yeah, nice to see you online. My name is Weri Kim, and today, Mr. Aaron Maruzer, who is a graduate student at UC Berkeley, he will present the summary report of PFAS in Saipan water system. So let's start.
Okay, thank you so much, Dr. Kim. Hi, everyone. I'm really excited. Thank you so much for inviting me. I'm really excited to be sharing the results of what we did over the summer. I'm actually in California right now, so I'm saying hi in the afternoon on the other side of the Pacific. I hope you guys are having a good evening or morning, excuse me. So let's just get started. I think before we start talking about the data, I'm kind of curious about how much you guys already know about PFAS. So for the folks, this is sort of for the folks already in the room. I'd love your participation in this. I'm going to ask 3 questions, and I'd like for folks to put their answers in the chat if you can. Starting off with the first question, which is just a true or false question. So without giving me the acronym, I want to know if you know what PFAS stands for. True or false? I see Heidi jumping in. I see yes, yes. Rob, thank you so much. Yes. I see a lot of people saying yes. Oh, a lot of people already know what it is. Cool. Okay. Nice. Okay. So it looks like I don't need to explain it too much. So for folks who maybe are a little bit shy and don't know what it is, PFAS stands for per and polyfluoroalkyl substances. I'm not really this isn't really a introduction into what PFAS are, but I'm happy to know that a lot of people already know or are already familiar with what it is. Here's the second question, and it's about some of the functional use of PFAS in many products. So it reads, PFASs are primarily used as blank. So we have either A, solvents, B, surfactants, C, flame retardants, or D, colorants. And again, if you could type in your answer into the chat, I'd love to see what people think. So Heidi coming in with C, Nicolette coming in with C. I'll give it like 30 seconds or so. C, Travis coming in with B. Interesting. So we got a little bit of a different response here. I'll end. If for anyone who's still thinking about it, I'll give you a few more seconds. Overwhelmingly, people are saying C. All right, let me reveal the answer because I think this is a little bit of a trick question. So the answer is actually B, surfactants. PFAS are primarily used as surfactants, and C is sort of the trick question or trick answer here, probably because of that title picture with the firefighting foam. People tend to associate PFAS with flames, but primarily PFAS are used as surfactants because of their surface, because they're made of a hydrophobic and a hydrophilic part, and they're really good at separating. They're used in firefighting foam as flame extinguishers, and flame retardants function to prevent fires in the first place. So it's kind of a trick question. Thank you so much for your participation. Let's move on to the last question. So this one is about some of the policy, sort of the policy arena of PFAS. Which of the following is false about EPA's lifetime health advisory level? So we have A, it's a non-enforceable level. B, it's set at 70 nanograms per liter or parts per trillion. C, it's different from a maximum contaminant level. Or D, it's based on 5 different PFAS compounds. And I'm looking for the lie here. So again, if you can put your answers in the chat, give it again, maybe 30 seconds before we move on. Heidi jumping in with D. Or maybe I should have included an answer saying, I don't know. Seeing a lot of D's now. Okay, cool. So it seems like we have a consensus. So that's correct. Everyone got it right. The health advisory level is not, PFAS are a diverse class of different chemicals, and the EPA's lifetime health advisory level is based only on 2 PFAS. So it's PFOA and PFOS. PFOA and PFOS getting a lot of notoriety these days. And in fact, like I was kind of alluding to it previously, but really it's not just PFOS and PFOA. There are really a lot of different PFAS out there in the world. EPA has been compiling and identifying different PFAS, and they've put it on EPA's on their website. Right now, I think there's about over 9,000 different PFAS chemicals that have been identified, and that list keeps getting bigger and bigger. And kind of talking about there are a lot, PFAS are sort of an emerging contaminant, so not just politically, but scientifically, and they're used in a variety of different consumer and industrial products, primarily as a surfactant because they're really good at resisting water, grease, oil, and stains. And so they can be found in various consumer and industrial products, either intentionally or unintentionally added. And they can lead through, you can sort of find them in your Teflon, you can find them in your Scotch Guard, your carpets, different product categories, your food packaging, nonstick pans, car seats. But most notoriously, we're really going to focus on is sort of the firefighting aspect of this, because PFAS are predominantly used in high concentrations in aqueous film forming foam, or AFFF, which tends to be where the source of PFAS is. A lot of drinking water is contaminated with PFAS, and a lot of that source comes from this AFFF. And so the goal of this report is really to take a lot of the existing data that are out there and collected by CUC, the Commonwealth Utilities Corporation, and sort of tell a story of the different PFAS concentrations, the PFAS that are, So we took existing data and we sort of analyzed that. We looked at soil samples. We looked at different PFAS concentrations in groundwater, in entry points, and in 2 single entry point wells, or entry points called IF28 and IF208 between 2015 and 2020. What was unique about this report is that it really expands. This is sort of the first time that a public report has been released scientifically about PFAS using that existing data that have been collected by CUC. And we're sort of expanding the scope, not just to look at PFAS and PFOA, but really try to look at the different PFAS that are out there. We're also going to, what's also kind of unique about this approach analytically is that we treated some of the non-detected values as error values and not zeros, and that was in order to avoid underestimating summary measures. So let me tell you a little bit about the 3 types of sort of samples that we organized. We kind of referenced to it in the last slide, but we looked at soil and we looked at water, and water could really be, we separated water into groundwater that was collected in well samples. We also looked at finished water, which was water collected or samples collected at the entry points. And what I want to emphasize is that the concentrations that we find in the entry points are basically are dependent on the concentrations that are located upstream. So what you find in the entry points is basically what you find in the wells, or is directly related to what you find in the wells, and which is related to what's collected in the soils. And there are many different analytical approaches to how we can analyze PFAS concentrations. And for this report, we kind of stratified according to time and space for the water data that we had, looking at PFAS concentrations at the wells over time and by space, and then looking at the PFAS concentrations at the entry points by time and by space. We also had more than PFOA and PFOS in our data set, and so we tried to look at the different PFAS that were detected in all of these different, not just in the water, but also in the soil. And of the things that we couldn't look at because we didn't have data, but we would like to explore, sort of digging deeper into the PFAS concentrations in each of these three points in the system. We could, if we had the data, we could also analyze how PFAS concentrations vary in the soil. If we had information about soil type and soil depth and wells, sort of looking at how deep each well is constructed, also the spacing between each well in relation to each other, and also sort of the production rates. And so more data, and the same sort of true for the entry points, all of which to say that I think we stratified according to multiple variables, and so we kind of had this complex system, but we could definitely go even further with more data available. I also want to emphasize that what we looked at is sort of midstream of this complex system. So in addition to all the complexities that are in looking into PFAS in soil, groundwater and entry points, there's also, the water that goes into entry points ends up in commercial institutions, and also households. We don't really have information about that. And even more upstream is looking into emissions information. So for Saipan, we're going to get into this, but the emission source is really aqueous, aqueous film forming foam used in the firefighting training facility in the airport. We don't really have information about production history or use history, what type of AFFF was used. All of this is sort of be integrated into an analysis, and could definitely create a more complex and thorough story. So of the data that we do have, we still have a pretty compelling story. And I want to start out with this bar graph, which shows the results of EPA's unregulated contaminant monitoring rule. And really the point here is to just show the levels of PFAS. This was the starting place for the PFAS story that happened in Saipan, and what I think anyone, I think this is a pretty obvious story. But this bar graph just shows the extent of the PFAS contamination that's happening in Saipan. So, and it's not just for PFOA and PFOS, it's also for, PFBS, the heptanoic acid, hexane sulfonate. So for 5 different PFAS, you see that Saipan had more PFAS in the water system than any other state in the mainland. So for PFOS, for example, the average concentrations of PFOS were about 13.6 times higher than the national average. But what I want to emphasize is that that distribution of PFAS wasn't even. In fact, most of that contamination was coming from IF208, which was located in the south. And it was, Isley Reservoir and Isley Booster 1, you could sort of see that the PFAS contamination was really hyper-localized in the southern region of the island, primarily in this area, with this facility here being the airport. And so what we found, what kind of PFAS were present in these 3 different points, I've sort of listed here with some of the averages, some of the average values and parentheses. And so we saw 28 different PFAS detected in soil, with the most PFAS, the highest average coming from this PFAS compound, PFPEA, then PFOS down to PFDA. And this was just the top 10 of the 28 PFAS that were detected in soil. In water, we found 6 different PFAS. Oh, excuse me. No, 6 different PFAS. PFOS being the most dominant, and then PFNA being the least. And then in entry points, we saw 7 different PFAS. Again, PFOS being the most dominant, and then hexanoic acid being the least. And so when you break it up by entry point, like by facility and by time and by different PFAS, you get a sense of what we can take a closer look at what the data is telling us if we just break it out a little bit more. And this is what this line graph is showing us. And so what we can see is that, well, the first thing is that IF208 still remains the most PFAS contaminated entry point. So notice the scales being much larger than anything else. Then comes Isley Booster 1, which then became Asterlahi Tank in 2019. And then Isley Reservoir down here coming in third. What we can also see, I think which I think is pretty starking, is that hexane sulfonate, PFHXS, this turquoise looking line, is strongly correlated with PFAS. So the changes of PFAS over time, you can see that the lines are really parallel to one another. Another PFAS that do exist in the system tend to be at much lower levels, and you can't really see a pattern with them, but they do correlate with one another, which really emphasizes the fact that PFAS are, so they don't exist in isolation. They co-occur in the environment because they're released as mixtures. And we can also see one of the big takeaways for me in this figure is also that because of CUC's efforts since detecting PFAS in 2015 and 2016, you can see globally, there's an overall reduction of different PFAS concentrations across the system, but there are still persistent peaks of like local maximums, and still, it's still a persistent problem. So in the next few slides, I'm just going to briefly touch on, so that's sort of the story that's happening in the entry points, and now we're moving upstream to sort of to look at the groundwater PFAS concentrations, and I'm going to take you through year by year what the PFAS concentrations were. And just to orient you for the next few slides, this figure shows a bunch of dots, and these dots are all color-coded, and these dots represent production wells that are located in the south. We're going to take IF208 as the point source, as our reference point, basically. Again, just to orient everyone to what I'm talking about. Each of these dots can be sort of organized into well service fields, where this is IF28, another single well entry point. Again, so these wells, each of these dots can sort of be grouped into well service fields, and each of them collectively serve a different entry point. So in the blue oval here, we have the IF series of wells, or the Isley field wells, which mostly serve Isley Booster 1 or the Asterlahi tank. In this purple oval, we have the Objan series, which mostly serve Isley Reservoir. And in the green, we have off to the west here, we have 5 wells, which serve KV 21 to 25 entry point. What I want to point out too is that you can pretty much see that the Objan wells are pretty evenly spaced compared to the Isley field wells, and I think that's becomes an important part of the story later on. This sort of spatial cluster of the production wells impact, kind of a sneak peek into one of the conclusions, is that the spatial cluster of these of these wells will impact the concentrations of PFAS that we find in. So in 2016, we had, in 2016, PFAS concentrations greater than 26.5 nanograms per liter tend to be found adjacent to or south of IF28 or 208 entry point. And you can see that pretty clearly in the graph. So wells pretty close to IF208 tend to have the highest quartile of PFAS. And then some wells that were, excuse me, some wells that were sampled down south also had higher quartiles of PFAS concentrations. In 2017, CUC took more targeted approach. So again, let me go back real quick. So in 2016, all of these different gray dots essentially mean that they were sampled and they were not detected. And this empty dot represents that it wasn't sampled that year. And as you can see that there was a lot of non-detection and that the concentrations tend to be hyperlocalized to this specific region. In 2017, CUC, in an effort to be more efficient with their resources, used more targeted sampling, and so sort of focused in on really adjacent wells and possibly impacted wells. And so we can see that the Isley booster wells had a mix of high and low concentrations of PFAS, with the lowest being sort of north of IF208. And the sort of the wells closest to IF208 still had very high concentrations of PFAS, between 79 parts per trillion to over 7,000. Again, in 2018, there were some changes, but the pattern basically remained the same. When you look down into the nitty-gritty of it, there were some sporadic changes. So for example, let me just flip back and forth and maybe you can spot some of them. So this is 2018, this is 2017. You can see that IF208, for example, went from higher to lower. And then some of these wells also from 2017 went from low to high. And some of these wells also changed in concentrations between these 2 years. 2019 was the last year and that we had in our data set. Again, the overall, the pattern globally, overall, the pattern remained the same, where you had sort of the northern wells being least impacted. And in the south, you sort of see maybe a little bit higher concentrations, particularly in this well and this well, but not a significant amount of contamination here. But you started to see more more PFAS being detected in the KV wells. And I think overall with this, what I sort of go into a lot more detail in the report, but the brass tacks of it is that PFAS concentrations will vary over time, and they can vary by a number of different factors. So one of the most important one being its proximity to IF208. We can see that across the years, the wells very, very close to IF208 tend to have the highest quartiles of PFAS. You could also see some of the spatial density of the wells are likely to play an impact on the concentrations of PFAS, particularly because, and this was shown in a different report by USGS, where chloride concentrations, those concentrations will be impacted, and they're impacted because of the spatial density of these wells, where in the IF208 wells, which are very dense, you'll get higher concentrations than if your wells were more evenly spaced out because of the magnifying drawdown effects. There are also changes to the system over time. So I kind of hinted at this, but since since PFAS was detected in the system in 2015 and 2016, CUC has voluntarily tried to meet the EPA's lifetime health advisory level by usually turning off wells in order to get the lifetime health advisory level to below 70 parts per trillion at the entry point. So as an upstream sort of intervention to reduce those concentrations over time. What happens is that when you turn off wells and you sort of change the aquifer to the extent that you're sort of inducing movement of PFAS in the aquifer. There's also a pretty strong showing of, there's pretty strong evidence that says that PFAS tend to flow south. And we could see that pretty consistently across the years because wells that were located up north of IF 208 tend to have low concentrations of PFAS. But one of the things that we kind of wanted to highlight, and we again talks a little bit more in depth in the report, was that over the years we saw that the KV wells were not super impacted by PFAS, but over time, you know, by 2019, you saw that there was more PFAS detected, and one of the hypotheses of what's happening is that if groundwater is flowing down south toward this this direction, it may not be likely for PFAS to be traveling westward towards the KV 21 to 25 or to these KV wells, which suggests that there may be another source of PFAS contamination in this area. Also, there are changes to how we analyze these different PFAS. So the method detection limits definitely matter in the story. There's also sampling frequency, where we saw that, again, in 2016, that was when CUC was looking at a lot of different wells and then sort of narrowed in on, used a more targeted approach, looking at different wells, and that might have a role in what you can and can't see. We also, you know, thought that maybe PFAS concentrations will vary in these wells based on individual PFAS characteristics. So what PFAS was being detected, or what PFAS you were looking at, will make an impact just because of chemical characteristics, unique individual characteristics of that compound. And we sort of started to explore that by looking at, again, stratifying, using this strategy of stratifying according, and we did that with this subzone analysis, where we took wells that were very close to IF 208 and looked at the 6 different PFAS that were present. And the numbers don't really matter for the point that I'm trying to make here, but what you can see is that basically what we expected is that the shape of these not histograms, box and Wister plots, should be consistent across these different wells. However, what you can see is that there's a little bit of sporadic patterns. There's a little bit of a sporadic pattern across these different PFAS for each well. So for example, PFOS and PFOA should look pretty much identical, and they look pretty identical except for IF 23, with IF 23 having higher PFOA than expected. We would sort of expect that PFOA would be like maybe down here. What this suggests is that there may be a difference in partition, or there may be a difference in mobility and transport of PFOA in the aquifer, which might be a result of again, intrinsic chemical characteristics, but also it may be extrinsic factors like some of the factors that I was just talking about, like changes to the system. Or it can be a combination of these different factors, and more research would be warranted. So where we go from here is, again, this is sort of a first pass into looking into the data more deeply. I think there's definitely areas where you could further investigate some of the unanswered questions that were raised during this analysis stage. So, for example, looking into flux and soil water partition coefficients for PFAS and other PFASs might be useful. Evaluating some of the intrinsic and extrinsic factors that influence the mobility and transport of PFASs over time, within a specific year. For groundwater flow is very likely to be impacted by rainfall events. And so looking into the relationship between rainfall or the wet versus dry season and changes of PFAS concentrations over those periods might be useful. And also looking into, the sort of this potential different sources of PFAS that could impact KV21 to 25 entry point. And then I think one of the things that that would definitely be useful is to try to collect more emissions information to sort of identify the most upstream leverage point, and try to sort of investigate where that fits into this larger story of PFAS in Saipan's water supplies. And that's it. Thank you guys so much. I will stop here and I'll take any questions if you have them.
Mr. Moroso, thank you for your presentation and your report on the PFAS. So we have a few questions in the chat, and since you are short on time, if I can ask you to address them in the chat. So our next agenda here, we have our open discussion. And then I'd like Dr. Jensen to start off our open discussion.
Thank you, Justine. We're at the point in the meeting now where we get to engage in some cross talk with one another, and that's the reason we're here. One of the advantages of this meeting every year, that people tell me from time to time, is that it's a rare opportunity to get everybody together in sort of the same space, the same cyberspace in this case. It's a unique opportunity for an interagency meeting. We have some other forums like the AWWA, which I think has been real successful lately in bringing us all together. But one of the advantages of the virtual meeting space, I noticed our numbers have been steadily climbing. We're up to 61 of the 67 registrants. So we've just about got a full house, so to speak. But one of the advantages of this space seems to be that we get pretty good numbers. So I'd like to invite y'all to begin the discussion. It's a little hard when you're talking to the screen and all you see is yourself. The little boxes with people's names in it, because I can't see people's faces. But I'd like to first of all thank everybody for coming, and ask you to take advantage of the form that GLEE has prepared to give us feedback. That written form is really, really helpful, because it's something we can pass around, or even an email back to the presenters or back to me. But let me just share a few thoughts with you to kind of get the conversation started. My presentation on what Weri does and who we are was admittedly a little Guam centric. And that kind of reflects the fact that we are doing a lot of work on Guam. And we would like to be doing more in CNMI and FSM. We'll be talking to the FSM constituents next week. But of course, we're going on 2 years now in COVID, and that is really, as everybody agrees, has slowed down the interaction. It's precluded us from being able to travel and do field work. And we're hoping that's over soon. But I'm reaching for ways to overcome the COVID barrier, and once the barrier is down, to recover from it and regain the momentum we had. So as we search for projects and problems to address, I'd also like to get your thoughts on how we can best connect and reconnect and keep the momentum going. And I'd like to invite my USGS colleagues to suggest what we might do to restore some of the kind of presence that USGS once had in CNMI. We once had a field office up there. I used to work with Rob Carruth. And I like say, I can't see anybody's faces, so I don't know who might have some thoughts on this, but I see John just lit up his screen here, so I'll invite him to follow me with some thoughts then. And let's just make this a freewheeling discussion and think about what we can do to expand and deepen the scientific support from both Weri and USGS and CNMI. So John, I'll hand the mic to you.
Okay, well, I will start, and I will also, I don't know if any of my USGS colleagues are still on, but after I speak, I'll invite them to chime in if they are. So yeah, your presentation was a really good summary of the work that you've done, and it was indeed somewhat Guam-centric, and it's understandable. And I know a lot of that work that you presented was aided by collaboration with the USGS. We've had just a very good, very healthy, productive relationship with Weri. The Weri USGS relationship goes back a few decades, and it's just been a great partnership. We have our respective roles and responsibilities and skill sets, and it's worked out really well. The USGS has in the past worked with the CNOI government, especially on Saipan, but also on Tinian and Rota, but mostly on Saipan. And most of that work in the past has been to collect basic hydrologic data to better understand the resources on the island. It started many, many years ago. I moved there in the late 80s and worked there until the early 90s. And we had a very small office co-located at CUC. Drilled a bunch of test wells, helped drill production wells. It was a pretty fruitful relationship. I left, and then Rob Carruth, many of you know Rob Carruth, followed me, and he was there even longer. He was there probably 6.5 years. I was there for 5.5. I think he was there for 6.5, something like that. In any event, it continued on and just continued to grow. But for one reason or another, mostly funding, the USGS had to scale back, and we left Saipan. Maybe about 20 years ago now. And so we haven't really, we've had an intermittent presence. We've gone back periodically to do small scale investigations, collect data here or there. We have recently re-engaged with CUC with Tim Bowden, I think his name is, and he's the new deputy director at CUC. And we are starting to have regular check-ins with him and Travis. And we're hopeful that that regular check-in will result in identifying areas where, you know, where we can provide some value added to the work that they're doing. There's a lot of things that we could do, of course, but you know, it's all resource limited, and it's so. But many of the things that we've done with Dr. Jensen and started to do in much of the work that we have done in Saipan with CUC and others, and Travis and others, could lead to much larger studies too, like construct groundwater flow models and produce more predictive type tools that could be useful. And in any event, we're really excited that we've re-engaged with the folks on Saipan to help where we can. So Dr. Jensen, I hope that's what you were looking for.
Yeah, thanks, John.
Yeah.
Make sure everybody.
I've got a bunch of noise in the background. I'm gonna turn my mute on.
Yeah, I just want to make sure everybody understands that John is the director of the Pacific Island Water Science Center in Honolulu, and is our partner in the Pacific.
And I think Stefan might be on and Jack might be on, but I don't know. Oh, well, there's Stefan.
I'm here. I'm here. No, I think John, you've summed it up really well. I'm new to this community, and it's been a great experience working with everybody and just kind of seeing the depth and breadth of the projects that are going on across the USAPI region. So really pretty darn lucky to be part of this community and have the relationship that we do with Weri and continuing to further that partnership. So thanks, Dr. J, for being there and kind of hosting those weekly get-togethers and whatnot to have those conversations and keep that all going. And we look forward to, as John said, some of the new opportunities that are kind of going on in the area and the different ways that we can kind of help support all of these island communities as a whole. So thank you.
So yeah, it's been a long time since I was there, but the person I remember really well is Heidi. Heidi, I won't tell any stories about Heidi yet. That'll wait.
Let me give Heidi an opportunity here to follow that line of thought. I think you're still muted, Heidi.
Sorry. Yes, sorry about that. Yes, John made me giggle when he said that. Yeah, we've known each other for a while. So it's great. And I really appreciate all the data and the resources and the time that USGS has provided to CUC. And I would like to see a presence back in the CNMI on a more regular basis. And it kind of looked like that was happening in 2019, but of course 2020 hit and everything got disrupted. So maybe things will change a bit in the next coming year.
If you were going to set up data collection program of some kind, such as the aquifer monitoring program that we have here on Guam, what would be the logical start to something like that? And I'm thinking in terms of something that we could leverage with our presence here in Guam to have principal investigators at Weri engaged with USGS resources and engaged with you guys to collect data on water quantity or quality that would be helpful to your resource managers. See,
My opinion would be that we need to have say a collaborative effort for several points. One, training first to with say USGS or Weri or UOGP personnel to train Saipan staff people to how to collect this, look at the monitoring wells. CUC or BECQ perhaps, or another agency could help, with the ground maintenance to access the monitoring wells. If you only go to them, 4 times a year, you're going to hit grass that's, above your head many times of the year, right? After rainy seasons. So you need to be able to find those wells and be able to get to them. And then being able to make sure that the equipment that you need is operational. So maybe we could start with that and see where it goes. And also, we need to make sure that we set up a program of how often we go to the various monitoring wells on a routine basis. There's so many things just happen, and there's short changes of staffing requirements, and CUC's got only a certain number of staff that can go out and do these certain things, and then big projects happen that they can't get the routine stuff done like this. It's sort of extra, and I'm not the one to make the decision on that. It would be other personnel, the water division manager probably.
Yeah. Thank you, Heidi. Again, it's hard when I can't look across the room and see people's faces, but would anybody like to comment on what sort of data it would be most valuable to be collecting that you're not collecting now, and what sort of analytical programs might be most valuable for the data that you do have with regard to either quantity or quality of water? Okay.
And Dr. Jensen, I think you're asking the folks in Saipan that question, right?
Right, but anybody who wants to comment, I've got colleagues here on Guam that work on projects in Saipan, members of the engineering community, who I'd be happy to get some suggestions from them. And our purpose is to kind of step back and review the needs for good water resource management. And so far I've been talking about data collection, but also included in our mission is, as you know, is training, professional training, outreach. And I was going to mention some of the programs that we have there, but if somebody has some suggestions for workshops on professional topics or outreach in your education system, we've got a good program that we call Water Kids, where we've been taking, I think Kaylin Bautista is logged on here. Kaylin, if you're there, you want to comment on the Water Kids program? I saw her there earlier.
I'm up at House 5 and there's just a bit of movement, but I'll go ahead and put it in the chat a little bit.
Okay. Yeah, Ken's been working with the school teachers here. We have contact in the Department of Education, and has been taking presentations. We've got an online resource. And pre-COVID, again, this is something that was affected by COVID like everything else, but teaching the teachers and teaching high school kids to teach the grade school kids. And it's been very successful and really well received. It surprised me just how enthusiastic people are about it. But we've got a little kit here that how to make an aquifer, and the kids learn about water resources in their science classes, and it's been so successful that people stop me in the grocery store that I don't even know and tell me about how interesting it was and how excited their kids were. And we can certainly extend that sort of thing if you've got connections in the school system. I see Mike Gell has lit up his video here. Mike.
Can you copy my question? I've got a question. Is something that perhaps the participants from Saipan and Cnmi could help me on. I was wondering, considering all the developments and activities that are ongoing and planned for Tinian, are there impacts on the wetlands and the groundwater there and rainwater as well being monitored?
You know, I don't know. 2015 was the last time I was out on Tinian with Doug Roth, and we did some surveying from some of the existing wells that were there to begin assessing the groundwater potential there. But yeah, there's work on Tinian and some work on Poggin too. If anybody wants to comment on Mike's question, please jump in.
Hi, Mike. This is Larry Morin with DEQ. I just wanted to say we're continuing our beach monitoring program, which includes Tinian. So we have several sites on Tinian that we're monitoring regularly. And then we also did a trip to Poggin that had several Cnmi agencies included back in June and July. And so we were able to collect some data in the marine environment for the first time for our agencies. So we're really excited about that.
Yeah, thank you, Larry. That's good.
Dr. Johnson, may I have one question?
You bet.
I will create a stormwater management model. For this, I need storm drain system CAD file for Garapan area. So, but as a new faculties, I have no connections. I have no idea about who has this kind of drainage system blueprint or CAD file and anything. Could you share your idea with me?
Yeah, it's a little hard to gauge people's who's ready to respond and who isn't. You can't.
Yeah, so many people are interested in stormwater and flooding.
Yeah.
So in order to build a stormwater management model, I need drainage, such as some digs or some pipelines or slopes, everything. I need this kind of information with CAD file or something. So I could get some weather data, but I cannot get any information about this drainage information. Could you share your idea with me? No.
I want to could we handle this is a question for our Glee people. Could we handle bandwidth if everybody turned their video on so we could kind of talk face to face?
Hello, Dr. Jensen, this is Justin. We could try, but we're not guaranteed because we have people from other places such as California and Saipan. We can try, sir.
Okay, I don't want to crash the system.
Yes, sir.
And I would like to suggest that at least when everybody's speaking one at a time, of course, turn your video on. But I think it might enable the conversation. Let's go ahead at the risk of bringing the system down here. Go ahead and turn on your video so we can kind of see each other's faces. I was going to I had a thought here that just escaped me, but Dr. Yeo was suggesting he needs data, and who amongst us has an interest in stormwater management? I guess, you know, if we were all in the same room together, I'd ask for a show of hands. But perhaps people with some thoughts on stormwater can talk to Dr. Ya now. He's our stormwater guy, surface water hydrologist, and is interested in finding out what your problems are and designing a research program to help solve those problems. So amongst the people that raised your hands, who wants to go first?
Hi, John. This is Robbie up on Saipan. I will jump in with a couple quick thoughts here. First would simply be that there are a number of projects either ongoing right now or upcoming that relate to stormwater and flood management, specifically with respect to our road infrastructure here. And so I think a lot of the work that Chris is going to be doing will be directly relevant to that. And if there are any needs in terms of looking at research results in comparison to on-the-ground conditions or anything like that, yeah, be very interested in helping out, and definitely looking forward to the data. The other thing I would quickly mention is we've been working on a project for about the last 6 months where we were trying to use some of the stormwater infrastructure data from CAD files and a few other sources to take a look at potential redesign and retrofit. And notice that there's some huge discrepancies among the various data sets, especially in terms of horizontal and vertical datums. So if folks are looking to apply some of the research results in tandem with CAD or GIS data for stormwater infrastructure, if you're looking to do like fine scale design sort of specs, you'd probably need to look into the source data just to make sure everything matches up, because we've had a lot of issues with that recently. But Chris, you can reach out to me separately, and I'll open up that can of worms in an email.
Okay, thank you so much. I gotta label my email address. Yeah.
Hey, Dr. Jensen. This is Travis Spaeth with BCQ. I guess going back to slightly a little previous is maybe some data we could try to collect in the future is, you know, updating. I know USGS came out and tried to update a lot of their data they've been collected with the groundwater here in Saipan, but a lot of monitoring wells were broken or inadequate. They couldn't actually collect data off them. So that's one thing we're looking at maybe fixing. But one thing we'd like to partner with you guys and them is maybe an ongoing data collection, you know, using CUC's wells on the water quality. It wasn't as easily to do prior, but now that CUC provides 24-hour water at least most of the year, maybe we could start making recommendations on what wells to reduce pumping rates, or try to make overall aquifer improvements rather than just pumping them 24 hours a day, and then having an operator just go shut a well off down in Isley just because the tank was overflowing or something. Maybe more
Right.
systematically approach this aquifer management. And we have started monthly calls with USGS, CUC, and myself, and hopefully we can elaborate on that and maybe even bring Weri into the mix. If you have some recommendations on what you've done in Guam. I saw your presentation about with PWA a few weeks ago, so that was something maybe we could replicate here.
Great. Yeah, I see we have some people on from GWA. Maybe there's some potential for sharing some ideas on approaches that we've taken here. With regard to saltwater intrusion and monitoring your salinity, what do you do now, and what would you do better if you could?
I think about all the data collection now is CUC collects 2 data points, 2 semi-annual water quality parameters. That's about the data we're getting. And that's all the wells on Saipan are supposed to provide that to our office. So we could get private wells as well and try to mix that into the fold. But I feel like that might not be enough. Although, it would give us a much better idea, I think, just compiling that. And our office is working on that currently. It's just not ready to be published yet.
So you compile like quarterly data on chloride in each production well, or
semi-annual?
Semi-annual. Yeah. How far back do your records go, and do you have a?
Oh, we got pretty good data. It's not consistent, but I think we got almost 20 years of data.
Yeah,
it's not.
Well, one obvious thing that has been real value here on Guam is correlating it with the rainfall record, and where we've got the deep monitoring wells, such as I showed you on that one slide here on Guam. We correlate the response of the lens to the rainfall record and then to the response of the nearby production wells. Just having that kind of database is it enables you to do a lot of good management. I mean, as you know, maybe I could get Mark Lander to comment on the rainfall database that he's kind of assembled. And I see Jack Mitchell just lit up his video there.
Yeah, just to add on to that a little bit, part of the limitations of having the semi-annual chloride data only is that it is difficult to tie to any continuous rainfall record. And so semi-annual is good for long-term trends if you have a lot of data, but it's really hard to determine any short-term responses to either management decisions and pumping changes or even rainfall to see exactly what is happening and why. You might get a good trend after a while with semi-annual, but it's hard to really attribute much to it at that resolution.
Yeah. More data are always better, but it costs money and time. So we could, would there be, I'm just kind of brainstorming now, but are there particular wells, maybe if you could just monitor 3 locations from which you could get quarterly or monthly data, would you be able to put your finger on the map right now and say, yeah, it would be these 3 wells, or Is that,
Off the top of my head, no, but a pilot program like that would probably be the best approach because yeah, it's not feasible almost with unlimited budget to do continuous data at 140 production wells in Saipan. And so maybe selecting one well field where you're about to make a change in pumping condition and monitor it before and after that change might give you a bit of a better idea of how effective that change would be.
yeah. Yeah, Travis, Heidi?
I mean, CUC's got a handful of higher production wells. Those would be what I would go to. Your KG 131, your SQ 150, your pick one down in Isley. Just yeah, I think that would be a good idea actually to get more of a monthly reading on some of these wells.
So Travis,
Yeah, go ahead, Heidi.
Travis, are you looking for, say, monthly readings at, say, Cagman 131 for what parameters?
It'd be your normal water quality parameters you guys do.
Yeah, okay.
Semi-annual.
Yeah, because I mean, I've just noticed that KG 131's higher chloride concentration in the last years, several years.
Yeah, I've been getting complaints from the public about Cagman water being extra salty.
Mm-hmm.
Not good.
No.
Is Mark Lander?
Yeah, I'm here, John.
Yeah, Mark, you want to comment on the meteorological database or data collection that you?
Yeah, for just the rainfall.
Yeah, just sort of the state of the data.
Yeah, the rainfall is the official rainfall from the airport is it's correct in the sense that there's no inherent error in it. It's daily. Anderson Air Force Base is another good site, and it's wetter up there and more represents our northern lens. It has some curious differences between what you can get from the hourly record and what's somehow entered in their Form 6. It's not, you're not going to be off by more than 10%. It's not like temperature where there's some egregious mistakes or the method changes the whole picture of temperature. Rainfall, and there's a lot of stations, some just daily. Guam is covered. We have probably a dozen from the north to the south, from the wastewater treatment plant to Anderson. There's a lot of, you can do some good ISO heights, at least for storms, for the daily. You can get statistics for hourly. I even have 1 minute rainfall for 15 years from 3 or 4 rain gauges for Guam. But those statistics of extremes should be the same and I have it for typhoons. So whatever you can gather for typhoons, which is not in any official database. But I had rain gauges, Chip and I, for the TRIM project. We had shipping bucket rain gauges that survived typhoons, and we got some incredible statistics show just what happens during a typhoon, from 1 minute rainfall all the way up to the hourly to whatever. But those I only have. If you're looking for that short term.
Let me invite our NOAA contacts, Steve and Robbie, anybody else in the weather business that's in the meeting to comment. What sort of data do we have for Tinian and Rhoda as well as Saipan?
Saipan has a Fisher Porter on Capitol Hill for hourly.
Yeah, hi. This is Brandon Buchan from NWS Guam.
Go ahead and turn on your video if you can, Brandon.
Okay. All right. Can you see me now?
Yeah.
Okay. Hi, everybody. I've been jumping in and out because I'm on shift doing other responsibilities. But yeah, so CNMI, we have several rain gauges on Saipan. As Mark mentioned, we do have Fisher Porter rain gauges at the airport and up at Capitol Hill. These rain gauges have measure rainfall every 15 minutes, and the data is collected by CNMI EOC. The one at the airport is co-located with the standard rain gauge that Mark has referenced as CHIP's manual rain gauge. So those show very good agreement with because they're right next to each other. And then for Rhoda, we also have a Fisher-Porter rain gauge there as well. And again, those measure 15-minute temporal resolution data. And then we also have 24-hour rainfall from Rhoda Airport and Tinian Airport that the aviation kind of people measure every day. So that's kind of the overview of at least the Weather Service's equipment.
Those data are readily accessible.
I will write my email in the comments, and if anybody wants to try to access some of this data, I will be happy to help provide it.
Great,
that might be the best way, because it can be a bit troublesome if you're not familiar with extracting the data.
Right. Yeah. You usually have to have somebody answer a question or two.
Right.
Yeah. Yeah. Thanks, Brendan.
Sure thing.
Yeah, Robbie.
Oh, I was just going to mention that all the data records from the gauge at American Memorial Park should be available. I'm not sure if Mike has any more information on that. I see him nodding his head.
Yeah, thanks, Robbie. I retired almost 2 years ago from Park Service, so I don't know the present status, but I know the rain gauge and wind measurements and things at the American Memorial Park seem to survive through the bigger typhoons even, and should have continuous remote monitoring that the Park Service in Hawaii keeps records of, and should be made available as far as I can recall. Thank you.
Yeah, this is Brandon again. Just to touch on that, Dave Simmerl at National Park Service, I think he was the one that first set that up. It seems like last month's data from the MPS was a fair bit lower than a lot of other sites. So I do wonder if it's in need of maintenance. But that is an excellent data source, and it's very easily accessible, the monthly data, even the daily data for that site there. And it's in Garapan, correct, Mike?
That's correct. It's in Garapan, and next to the main harbor and a lot of the resort developments. I wouldn't be surprised if the lack of manpower in the last year or so at National Park Service has fallen down on the maintenance there, and I think that needs to be requested and promoted to maintain that station. Thank you.
Okay, let me shift the conversation to some of our colleagues in the private sector here. You know, over the years, we've done training programs of one kind or another, and I don't want to put him on the spot here, but for instance, in FSM, Ken Rectal from DCA here has worked with us from time to time, and in these research grants, we sometimes can, put together a little contract to sign up the people in the private sector to work with us. And it gives you an opportunity to network and meet with people, and the contacts that we make through the training pays off in research as well. So I'd like to explore the interest and opportunity for professional training. You know, global learning and engagement can arrange for you to get professional development credit for engineers and other people that might be able to use training points for professional certification of one kind or another. So if there's an interest, sort of a market for that, I see there's several people from the professional community here on Guam. I saw Nick Manley, Dustin Agnew. Like I say, it's hard without seeing your faces whether I'm putting you on the spot or not, but if somebody'd like to contribute some thoughts on that, I'd be grateful to hear from you. Let me call in the Weri faculty here to share some thoughts. Chris spoke. We give Dr. Kim a chance to contribute some suggestions.
Yeah, I think most of people know where we will have a new building within 3 or 4 years. And the one of main purpose for this new building is to expand our Weri water quality analysis lab. So if we have a new lab and that we are planning to expand our water quality analysis services. So in the meantime, we can talk with other people inside CNMI and CNMI and FSM regarding their status of water quality analysis. So I'm thinking how we can support other island, but from this year, I'm going to launch some basic research for the searching about water quality status in FSM. So based on this survey and then analysis, we are planning to expand how we collaborate each other.
Yeah, thanks, Dr. Kim, for bringing that up. Yeah, that's a good point. Our water quality lab has clients from Saipan and FSM, and we serve the commercial sector as well as researchers. And as Dr. Kim just mentioned, we're going to be doubling the floor space in the lab. We're looking at increasing the staff and increasing the volume of present services, plus increasing the services lab. So there's going to be a real expansion of opportunity in laboratory supported work here, starting year after next. We should have that building, as Dr. Enriquez mentioned. We're looking at having the design for the building approved next year and the building up the following year if everything goes well. So we should be in business in 2023. We got about 5 more minutes. Yeah, I'd like to encourage everybody to fill out the form that Glee provided and send us your suggestions. Let me solicit another kind of response here on another issue, coming back to one that I alluded to previously, and that is just COVID survival techniques here. Since we can't travel the way we once did, and I'm hoping that'll be over in a few more months, but a few months ago I thought it was going to be over by now. But what from your perspectives can we do? Should we have a regular little meeting space that we might set up and do some sort of online seminars? Or if we have to operate in the COVID environment for another 6 months, which will be into our next funding period, perhaps we should have, if we can't do training by coming to your location, we could do online sort of training. And that's just a suggestion, but what are your thoughts on something like that? Let's see, anybody else on the Weri faculty? Let's see, Dr. Nguyen or Dr. Lander. Mark's spoken a little bit there.
Is that John?
Mark, you have any suggestions? Let me just kind of go around the room here and ask for some final thoughts here before we close down the meeting.
No, it's just, there's nothing, almost no substitute for traveling, getting to FSM or Saipan. Especially FSM, where a lot of the work is field, outside, setting up rain gauges, studying the watershed. So I don't know how you get around it. The only thing we've been doing for the last 18 months is sort of behind the scene legwork, just collecting and data and building up data sets. And none of the active field work. Of course, they can do that, like Robbie Green and company can do field work on site, but it's hard to be there, see exactly what's going on. Yeah, I don't know how you take care of it unless we're directly collaborating on certain projects. You could, I mean, the same kind of thing. You could collaborate on email or however.
Okay, well, let me call on my USGS colleagues for some final thoughts. John or Stefan or Jack.
Sorry, I stepped away. And I know that Stefan had to sign off for other duties as assigned. So your question refers to what, Dr. J? I'm sorry.
Well, just I was thinking of a couple of things. One was what kind of training opportunities, and maybe in the COVID environment, if we have to cope with it for another year, knock on wood, in the COVID environment, maybe we should kind of shift from research to training and information sharing. And
right. Yeah.
What might we do to at least maintain contact with each other and maintain the working relationships that we've got?
Well, I like the fact that Travis and I and others, Tim, and you're welcome to join others. We're gonna resume our monthly calls just to talk about information needs. Now, that's not specifically training, but it will help in identifying what type of training would be needed down the road. But we should look for opportunities when they present themselves. Like, for example, the training that we're providing the Weri folks on the borehole geophysics that's coming up.
Right.
Now, that's pretty unique. And it's going to be pretty specific to the Weri folks. But there's opportunities like that might come up every now and then. I don't know if we could expand that.
Okay.
Probably too. Yeah. Anyway, but let me put some thought into that.
Yeah. Thanks, John. Okay. Well, we've pretty much run out the clock. I'd like to thank everybody for coming and for your participation. I think we were up to 65 or something our participants out of 67 that were signed up. So we've had good participation, and I hope the information has been valuable. It certainly is good to hear from everybody and see some faces and stay engaged in spite of the COVID challenges. So let's stay in touch with one another and keep the pipelines open. And we're eager to get your suggestions and advice on what we can do to leverage the resources we have and expand in some new directions. So I'll before we sign off, I'll just invite any last questions or comments that somebody might want to. Well, thanks everybody for coming. Next time we do this, I hope we can all be lining up for lunch at the buffet in the PIC or some similar kind of place. So hold that thought and stay in touch, and let's just keep on working together and having fun. Thanks, everybody.